Use the method of proof by induction to show that the sum from 1 to n of 1 over r plus 1 is equal to n over n plus 1. So first thing always with proof by induction is we try the n equals 1 case, and in this case the left hand side is going to be 1 over 1 times 2, which is a half, and then the right hand side would be 1 over 1 plus 1, which is also a half. So that is true for n equals 1. Then the next thing is always assume for n equals k. So what we're saying is that 1 over 1 times 2 plus 1 over 2 times 3 and so on up to 1 over k plus 1 is equal to k over k plus 1. And then we look at the next case. So in order to do that, what we're going to do is just add the next term to each side, and the next term after this one would be 1 over k plus 1, k plus 2, and so that must be equal to k over k plus 1 plus 1 over k plus 1, k plus 2. So if this one is true, then this one's got to be true because all we're doing is adding the same thing to both sides. Now to get a common denominator on this right hand side, what I'm going to do is multiply top and bottom like so by k plus 2, and then we've got a common denominator, so we can add the fractions. So that will give us k plus 2 plus 1 all over k plus 1, k plus 2, and that's going to give me k squared plus 2k plus 1 over k plus 1, k plus 2, and the top factorizes to k plus 1 all squared over k plus 1, k plus 2, and so I'll end up with the target expression of k plus 1 over k plus 2, and then all you need is a closing statement.